Welcome back to All This Math. This is Professor Parker. If you're here, hit the like button. If you haven't already subscribed, make sure you hit the subscribe button. Also, if you have any questions about what we cover, I'm about to talk about chords in a circle, right? If you got any questions, please put your questions in the comment section. Or if you just got a comment, put your comment in the comment section. All right. You just want to, say something, you know what I'm saying? Put it in the comment section. Also, please share this video with at least one other person. All right. Now, let's get into this. Chords. First of all, what is a chord? Right? A chord is one of those geometric terms that you need to know, right? Because we need to know the language of mathematics. Geometry is part of mathematics. We need to know the language of geometry, the language of mathematics. We need to know how to read it, how to speak it, and how to write it. So in order to read it, we need to know the vocabulary. What is a chord? A chord is a line segment that goes from one part of the circle to another part of the circle. It has an endpoint on one part of the circle and the other endpoint on another part of the circle. So FD is a chord, right? Point F to point D, that's a chord. DC is a chord from point D to point C. That's a chord. All right. If there was a line drawn from point E to point C, that could be a chord also. Or from point E to point F, that could be a chord. Okay. A diameter, if you know what a diameter is, the diameter is a chord that goes from one edge of the circle to the other edge of the circle. But it's a special chord because it cuts through the center, right? This chord don't cut through the center. This chord don't cut through the center. If I drew a segment from point E to point F, that wouldn't cut through the center, right? A diameter is the only chord that can cut through the center, right? It's a special chord, all right? Kind of like the y-intercept when we're dealing with y equals mx plus b, or, any of the functions, right? The y-intercept is a y value. Functions got a whole bunch of y values, but the y-intercept is a very important y value out of all the y values. All right, so now there's rules about chords. Just like we have chords, there's rules about chords that we have to know. But let's first do this. Let's read the question, right? Well, let's read the instructions, I should say. Let's read the instructions, and then we kind of get an idea of what I need to know to figure this out. This says if M, this lowercase m stands for the measurement of. That's what it means. Lowercase m means the measurement of. If the measurement of arc FD, and how do I know this is an arc? Because that little curvy symbol up there on top, right? FD, it's got two letters. So that represents 2 points. That means this is a minor arc. Because when you deal with arcs, we got minor arcs and we got major arcs. The minor arcs are less than 180 degrees, meaning they smaller than a semicircle. A semicircle is half of a circle. Because what does the prefix semi mean? Half. Semi means half. All right. Or semi means half. So measure of arc FD is equal to this expression. Oh, they don't give us the actual numerical degree measurement. They give us an expression, an algebraic expression. So we know we about to have to do some algebra, which is cool because before you took geometry, you took algebra 1, most likely. All right. So you should be able to bring your skills of equation solving, linear equation solving to the geometry class. All right. Now, measure of arc FD equals 12x plus 7 degrees, and the measure of arc DC, another minor arc. How do I know that? Because it's only described with 2 letters. If it's described with 2 letters, it's a minor arc. If it's described with 3 letters, it's a major arc, more than 180 degrees, more than half of the circle. All right. Arc DC is equal to 18x minus 23 degrees. Now, first off, don't get scared because you see, algebraic expressions and, just don't look like regular. You know what I'm saying? Don't get scared. That's the one thing. If you get scared, you're not going to be able to think clearly, right? And you probably won't be able to get the answer. So relax. Take a deep breath. Inhale, exhale, right? Have some confidence in yourself. All right. Have some confidence in yourself. Plus, right now, I'm about to show you how to do it. So all you got to do is pay attention. Pay attention. If you have any questions about anything I do what I said. Put your questions in the comment section. That's all you got to do. Put your questions in the comment section. All right. Now, find measurement of major arc. See, 3 letters. 1, 2, 3. 3 letters. Major arc FEC. Now, where is arc FD? Arc FD goes from point F to point D, but it's not the chord, though. It's the arc, right? Arc is like the pizza crust. If you think of the circle as a whole pizza, the actual circle is the pizza crust, right? Inside, you got the cheese and the sauce and the other toppings, right? But the edge is the crust, right? So that's arc FD. And then this is arc DC, right? And then arc FEC goes from point F through point E to point C. It don't go this way because if it went this way, you can't go from F and hit E second and hit C third. You follow the order of the letters, F to E to C, F to E to C, point F to point E to point C. So we're looking for the measure of this arc, right? Now, we don't know nothing about the measure of this arc yet, right? But with some stuff that we can figure out based on what we see here, this diagram, right? There's a rule about chords you got to know. All right. Now, this is where the critical thinking part of geometry comes in. This is what geometry is good for. It helps us develop our critical thinking ability, which helps us develop our problem solving ability. And in everyday life, we're going to have problems. In everyday life, we need critical thinking ability. That's the purpose of geometry class. So if you ever sit in a class, well, that's one of the purposes. It's a lot of purposes. It also helps you develop your logic, your ability to understand logic and use logic, right? But if you ever sit in a class thinking, why I got to learn this? Why, how is it going to help me in life? I'm never going to need this. You're never going to need problem solving skills. You're never going to need to know how to think. You're never going to need to know how to use your brain. Oh, that's right. Some of y'all are going to say, oh, I could just ask my iPhone. Yeah, okay. What if the iPhone is wrong? What if the person that programmed the iPhone didn't know what they was talking about? Or what if they did know what they was talking about, but they wanted to manipulate you into thinking a certain way? So they programmed it a certain way, knowing that all you're going to do is listen to your iPhone. Then you become a slave to your iPhone. Ask yourself, is that what you want? You want to be a slave, right? Now, I use my iPhone for some things, but it's a convenience, meaning it's an option. It's not like it's my only option. I have a brain. I know how to use it. I may use my iPhone as a backup, as a supplement, right? But that's not my only resource, right? My brain is my first resource. Because again, how do you know that the iPhone is right? Or how do you know that the person that programmed the iPhone is not going to program it a certain way to get you to act a certain way and respond to a certain thing a certain way so that they can just manipulate you and control you? You don't know that. At the end of the day, this is Western society. This is America. This this has been happening for years, literally hundreds of years. So keep that in mind, right? For anybody that say, I don't need to know how to think because I got an iPhone. Or maybe you got an Android. Somebody might say, I don't need to know how to think because I got an Android. Just something I want you to think about. So I just want to put that out there. But anyway, um, there's some rules about chords that we got to know. For one is, if two chords are equidistant, what does equidistant mean? They're just as far away from the same point, right? If two chords are equidistant from the center of a circle, that means those chords are congruent. I'm going to say it again. If two chords, 1, 2, we talked about what chords are equidistant from the center of a circle, meaning this chord is just as far away from the center as this chord is. This chord and this chord, that's equidistant. The prefix equi means the same or equal, right? If two chords are equidistant from the center of a circle, that means that those chords must be congruent. That's one of the rules of geometry that we use. Further, if two chords are congruent, then that means that the arcs that they create, right? So chord DC creates arc DC. Chord FD creates arc FD. If those chords are congruent, then the arcs they create must be congruent. So now, because of that, now we can work with that. We can work with that, right? And what I did with my points, check this out. Here's your little history lesson. And it's some Baltimore history, right? I'm going to use purple for the Ravens, right? This stands for Eddie Conway, Grand Marshal Eddie Conway. Grand Marshal Eddie Conway, rest in peace. He was a member of the Black Panther Party for self-defense in Baltimore. Then he ended up becoming a political prisoner. He was in prison for many, many years, right? He was released, and then he lived a few years. I'm not sure how long he lived in the physical after he was released from prison, but he was a member of the Black Panther Party for self-defense, the same Black Panther Party that was founded out in Oakland, California, in 1966 by Huey P. Newton, Bobby Seale, Lil Bobby Hutton. You know what I mean? Actually, no, it was before. No, it was 1966, October. In fact, October of 1966, right? That same Black Panther Party, they had branches all over the United States. And in Baltimore, a brother named Eddie Conway, Grand Marshal, known as Grand Marshal Eddie Conway, was a member. So the EC are his initials. Also, somebody else that spent time in Baltimore, wasn't necessarily from Baltimore, wasn't born there, but spent a lot of time there, Frederick Douglass. And the B in the center stands for Baltimore. So we got Frederick Douglass and Grand Marshal Eddie Conway. That's your history lesson. See what happens when you come to all this math? You're going to learn some geometry and get some history at the same time. See how that works? All right. Where else? Where they do that at? Where else can you get that? Ask yourself. All right. Now, because we know that these arcs are congruent, because we already talked about that, the arcs got to be congruent because the chords are congruent. The chords are congruent. If the chords are congruent, the arcs got to be congruent. So now, let's write that. Let's write that. Let's say arc FD, Frederick Douglass, is congruent to or equal to arc DC, right? So that's our statement, right? That's our statement. That's our equation. But then we're going to replace these arcs with their algebraic expressions that represent them, and then we're going to solve for x. Now, before we do that, I want you to know why. Always know why. And when you're sitting in a math class or you're watching somebody go over a problem, make sure you ask the question why. Like, why are we doing it? But make sure you ask it in a way that's polite so the teacher don't just think you're trying to be a jerk. You know what I'm saying? Right? Just ask, make it sound legit, right? You know what I mean? Because you really want to know why. Like, because if you know why, then when it's time for you to do a problem on your own, you'll have a better idea of what to do, right? The reason that I'm going to solve for x is because once I solve for x, I'll be able to figure out the arc measure of FD and DC. Once I figure out the arc measure of FD and DC, because I know that a whole circle is 360 degrees, right? What's my main goal? I want to find the measure of the major arc FEC, right? So if I know the whole circle is 360 and I know that FEC takes up almost the whole circle except for this arc and this arc, then all I got to do is 360 minus whatever these two arcs are. But in order to know what these two arcs are, I got to solve for x. Because once I solve for x, then I can plug x in and say, oh, well, arc FD is whatever. And then I don't even got to do the same thing for DC. You know why? Because I already said that FD and DC were congruent. So since FD and DC are congruent, I just got to solve for one of them. I got to evaluate, I got to evaluate one of them. And then I'll know the measure of these two arcs. And then I just take the measure of those two arcs, combine them, and then subtract their sum from 360, because 360 is the whole circle. So I want only from point F around past E to point C, right? That's why. That's why we're doing the equation. So make sure you understand. And I'm trying to get into the habit of making sure I explain why I'm doing what I'm doing, right? Because you want to also think about, because when it's time for you, like I said, when it's time for you to do a problem by yourself, you want to know why you're doing the step you're doing, right? So it could be logical and it can make sense. All right, so look, FD is the same thing as 12x plus 7. So check this out. We're going to do 12x plus 7 is equal to arc DC. Arc DC is 18x minus 23, right? So that's our equation. Now, once we set up your equation, we're not even in geometry no more. Now we're back in algebra 1, right? We're back in algebra 1, linear equations. If you do not know how to solve linear equations, I got a whole playlist with 50 plus equations on it, or 50 plus videos on it, right? Whole playlist. I got something for you. I got what you need, right? In this channel, make sure you subscribe. Go into the list of playlists. Go to the playlist that's called Solving Linear Equations. Solving Linear Equations. Go there. All right. Now, 12x plus 7 equals 18x minus 23. There's a lot of ways I can start this off. There's a whole lot of ways, but I'm going to do this. Watch this. I'm going to get rid of this 7, right? I'm going to get rid of this 7. Boom. Minus 7. But I got to keep it balanced. If I subtract 7 on the left, I got to subtract 7 on the right. But I'm not subtracting 7 from 18x because they're not like terms. I repeat, I'm not subtracting 7 from 18x and getting 11x. That's wrong. Don't ever do that. They're not like terms. You can only add or subtract like terms. An x and a constant are not like terms. An x and a constant are not like terms. I subtract the 7 from negative 23. 7 minus 7 is 0. Bring the 12x down. Bring the equal sign down. Bring the 18x down. What's negative 23 minus 7? Make sure you know how to subtract negative numbers, right? Negative 23 minus 7 is not negative 16. This ain't that. Negative 23 minus 7 is negative 30. You got to know how to do that. You got to know how to do that. You got to know how to do arithmetic with positive and negative numbers. You got to know how to do that. You got to bring that skill to the table. Now, I got x's in too many places. This is an issue. I need to have an x in one place. So I got to figure out how to combine these x's. So what I'm going to do is I'm going to subtract 18x on the right-hand side. I'm going to subtract 18x on the left-hand side. These are like terms. They both x's. They both x terms. 18x minus 18x is 0. 12x minus 18x is negative 6x. which is equal to, bring the negative 30 down. Negative 6x equals negative 30. So negative 6x is equal to negative 30. How do we get x by itself? We got to get rid of the negative 6. We got to get rid of the negative 6. But how, though? But how? How? Opposite operation. Opposite of what? What the negative 6 is doing. What's the negative 6 doing with the x? They multiplying. What does negative 6x mean? Negative 6 times x. You got to know the language of algebra. Again, the language. You got to know the language. Be able to read it, speak it, and write it. Read it, speak it, and write it. The opposite of multiplication is division. So we're going to divide, and we're going to keep it balanced. If I divide on the left, I'm going to divide on the right. Boom. Negative 6 over negative 6. I'm left with just 1x. Negative 6 divided by negative 6 is 1, leaving me with 1x. 1x and x are the same thing. They're the same thing. 1x and x are the same thing, right? I'm going to bring this up here. I'm running out of space down there, right? So I got x on the left side. What's on the right side? You got to know how to do division with negative numbers. What's negative 30 divided by negative 6? Positive 5. Not negative 5, positive 5. And you got to know your division facts. That's another thing. You got to know your division facts. You got to know your division facts off the top of your head, just like your multiplication facts. You got to know that too. All right, so x equals 5. Now that I know that x equals 5, I can go back and say, well, what's FD? FD is 12 times 5 plus 7. That's 60 plus 7. 12 times 5. Again, know your multiplication facts. What's 60 plus 7? 67. So that means that this arc has a measure, not a length, but a measure of 67 degrees. If the arcs are congruent, that means DC is also 67. But wait, hold up. Watch this. Let's prove it. What's 18 times 5? Again, know your multiplication facts. 18 times 5 is 90. What's 90 take away 23? 90 take away 23. 90 take away 20 is 70. 70 take away 3 is 67. All right. So now I want to know from point F all the way around to point C. The whole thing is 360. Now I'm going to subtract the sum of these two, right? Because I want the whole circle except for these two pieces. So I got to subtract the value of these two pieces. 60 and 60 is 120. 7 and 7 is 14. 120 plus 14 is 134, right? 120 and 14 is 134. So I'm doing 360 minus 134. What does that equal? 360 minus 100. I could use a calculator, but I don't need to. I could do the mental math. What's 360 minus 100? That's 260. What's 260 minus 30? That's 230. What's 230 take away 4? 226. Therefore, the measure of major arc, and it's a major arc because it has 3 letters. So we know it's described with 3 letters or 3 points. So therefore, we know it's going to be greater than 180. And 226 is, in fact, greater than 180. From point F around to point C, right? FEC, right? Major arc FEC is 226 degrees. That's what we have. Okay? So we got 226 degrees. All right? Like I said, any questions, please put your questions in the comments. All right? I look at the comments. I see them, right? I respond to them. If you have a question that addresses something from the problem, then, I might make a follow-up video just pertaining to your question, just to look out for you, just to hook you up. All right? Because I want to make sure we understand this. All right? Because math should not be one of our problems. Math should not be an obstruction to us getting certain types of employment, majoring in certain majors in college. Math should not hold us up. Like, I can show you how to do it. I can show you how to do it. All right? That's what I'm here for. That's what I'm committed to. Showing y'all how to do it. Showing people how to do it. All right? Now, so that's going to be 226 degrees from major arc point F around past point E to point C. Again, the whole circle is 360. That's a rule you got to memorize. The whole circle is 360, right? So if the whole circle was an arc, it would be 360. But we don't want to include this arc FD and this arc DC. We don't want to include those. So that means if we don't want to include it, we're going to subtract it out. 360 minus 67 minus 67. 134 is equal to 67 plus 67. 120 and 14, 134. 360 minus 134 gives us 226. All right. So understand the process. And understand you got to know how to solve linear equations. All right. So hit up my playlist, Solving Linear Equations. if you need a refresher. All right. Hit the like button if you didn't already. Subscribe if you didn't already. Share this video with at least one other person. And like I said, if you got questions, put them in the comments. I'll see you later. Peace.